A single rock, one you can hold in your palm, was quietly pulling drinking water out of swamps, rivers, and floodwater for over 4,000 years before the water treatment industry existed. Roman engineers built it into their aqueducts. Persian cities used it during sieges when supply lines were cut. Indigenous communities across 3 continents figured this out independently, without sharing notes, without modern chemistry, because the results were that obvious. And then, somewhere between the Industrial Revolution and the rise of municipal water systems, it vanished. Not because it stopped working. It still works. It works today. You can buy the material for $5, set it up in 20 minutes, and run genuinely contaminated water through it. We're talking river water, flood runoff, cloudy brown water from a ditch, and what comes out the other side is dramatically cleaner. So why don't we talk about this anymore? That's exactly what we're going to get into. Most people don't think about their water until the moment it stops being safe. A hurricane knocks out the treatment plant. A flood contaminates the well. A wildfire disrupts the municipal supply. And suddenly you're standing in a store watching strangers clear the bottled water shelves while you do the math. A case of water lasts maybe 2 days per person. A week of emergency prep costs you $60, $80, $100 in plastic bottles. And even then, you're assuming the store has stock. The water treatment industry has effectively trained us to see clean water as something that comes from a system, pipes, chemicals, infrastructure, rather than something humans have managed independently for millennia. That dependency isn't accidental. When you're paying monthly water bills, buying filtration systems at $200 minimum, replacing filter cartridges every 3 months, someone is profiting from the idea that you can't do this yourself. But here's what they don't tell you. You absolutely can. And the material that makes it possible costs less than a fast food lunch. Here's where this gets uncomfortable. This technique didn't disappear because something better replaced it. It disappeared because the infrastructure that replaced it was expensive. And expensive infrastructure requires customers who believe they have no alternative. Zeolite, the mineral at the center of this, was documented in Roman engineering texts. In 1756, a Swedish mineralogist named Axel Kronstedt formally identified and named it. By the early 1900s, zeolites were being studied intensively for water-softening applications in industrial plants. Patents were filed, research was published, and then municipal water treatment scaled up, chemical chlorination became standard, and the commercial water filtration industry built itself around proprietary cartridge systems, synthetic membranes, and replacement parts. Zeolite quietly got reassigned. Today it's used in industrial wastewater processing and fish tank filtration. The exact same material, just not marketed to you as something you could use yourself. Why? Because a $5 bag of rock that lasts for months and can be reactivated indefinitely doesn't generate subscription revenue. That's not conspiracy. That's just business. But it means most people have never heard of it, and that gap is worth closing. The rock is called zeolite, and if you've never heard that word, that's exactly the point. Zeolite is a naturally occurring volcanic mineral, formed when lava meets seawater or alkaline groundwater, and the silica crystallizes into a rigid, porous lattice structure. Picture a sponge made of microscopic tunnels, each one sized precisely to trap certain molecules while letting water pass through. That molecular sieve effect is real, measurable, and well documented in peer-reviewed research. Zeolite binds ammonium, heavy metals including lead and arsenic, and suspended particulates. It doesn't just block particles the way a cloth filter does, it chemically captures them. You need 3 things to get started. First, clinoptilolite zeolite. That's the specific variety used for water filtration, available in pool supply stores, aquarium shops, or online for around $5 per pound. Second, a container with a drainage hole. A 5-gallon bucket works perfectly. Third, a collection vessel underneath. That's it. No electricity, no proprietary parts, no subscription. Let me walk you through exactly how to set this up with nothing but a $5 bag, a container, and water you wouldn't dream of drinking. First, rinse your zeolite thoroughly. Run clean water through it until it runs clear, which removes surface dust from processing. This takes about 2 minutes. Next, layer your zeolite into the bucket to a depth of at least 4 inches. Deeper is better. 6 to 8 inches gives you more contact time, which means more effective filtration. Now, slowly pour your source water, river water, well water, whatever you're working with, directly onto the zeolite bed. Don't pour fast. Slow and steady lets the water saturate the material and pass through at the right rate. What drips out the bottom is visibly different. Turbid brown water comes in, clearer water comes out. Independently conducted tests on clinoptilolite filtration show reductions of up to 95% in ammonium concentration and significant reduction in heavy metal content. 1 pound of zeolite, $5, can process hundreds of gallons before it needs reactivation. And reactivation You rinse it with a diluted salt solution, let it dry, and it's ready again. The same material, reused indefinitely. Before you go buy a bag, there are 3 things you need to know so you don't make this less effective than it should be. 1. Zeolite is not a complete purification system on its own. It excels at heavy metals, ammonium, and suspended solids. It does not eliminate all biological contaminants. For water from questionable sources, especially in a survival situation, you should follow zeolite filtration with either boiling or a secondary activated carbon layer. Think of zeolite as stage 1 of a 2-stage system. It does the heavy chemical and particulate work, and boiling handles the biological. 2. Particle size matters. Coarser granules, around 2 to 5 millimeters, give you better flow rate. Powdered zeolite clogs. When you buy, look for granular, not powdered. 3. Depth equals performance. 4 inches is the minimum. If you want serious filtration, use 6 to 8. Multiple buckets stacked is even better. The point is, you're not locked into one configuration. You can scale this. 1 bucket for personal use, 3 stacked for a family. You have more control over this than any commercial filter lets you believe. 1 rock, $5, and a method that civilizations trusted with their lives, and somehow we forgot it. That's the real story here. Not that this was violently suppressed, but that it was quietly deprioritized while an industry built itself around the assumption that clean water requires their products. It doesn't. It requires knowledge. And knowledge, once shared, doesn't go back in the box. So here's what I want you to do. 2 things. First, try it. Get a pound of clinoptilolite zeolite, set up a basic filter, and run some water through it. You will see the difference with your own eyes. That's not a claim. That's a test you can run yourself in an afternoon. Second, share this with someone who needs to know it. A neighbor, a family member, anyone who's talked about emergency preparedness and doesn't have a water solution yet. This channel exists for exactly this reason. To pull techniques out of the margins of history and put them back where they belong, in your hands. If that's the kind of thing you want more of, subscribe. There's a lot more where this came from, because the best tools were never the most expensive ones. They were always just the ones someone forgot to tell you about.